So the stupidest thing I could do right now was ask people what the definition of DevOps is, given you just sat through 2 days of DevOps talks and presentations and probably learned a lot about DevOps. But why did I even come up with this talk, right? And if you look at the title, it's called From Apollo 13 to Google SRE, When DevOps Met SRE. How many of you know what SRE is? Okay, quite a few people. Excellent. There was a talk yesterday, right, on SRE? Okay, perfect. So hopefully you knew about SRE before that. And I don't know why the rest of the people are not raising their hands if you were on the talk yesterday. So we'll talk about that. The reason I ended up what became the talk was the beginning of the year, maybe around February, March timeframe, I had a client ask me, so Sanjeev, I'm hearing about this thing called SRE. What's the difference between SRE and DevOps? Where do they intersect? Should I be doing one or both? And I did my Michael Jackson flash dance because I didn't know the answer, distracted them by saying, oh, look at the shiny object over there, and left the room because I didn't know the answer, and I said, I need to do some research. So the first thing I did was I went and got this book. Because when I started searching on SRE, this book kept coming up, Site Reliability Engineering. I had seen the book before. I had heard about it before, but I totally ignored it because I thought it was all about maintaining websites and making sure they were reliable. And that's what Google calls it, Site Reliability Engineering, because that's what they do. They make websites and they run websites, and its roots lie in the organization which ensured the availability and stability of their core websites. They're obviously a web-based company. I think personally that we should call this practice service reliability engineering, because that's what they're talking about. And that's where I refer to it. In fact, that's how IBM calls it. We call it cloud service management in our own terminology at IBM. So there are several, so it's Google's approach to service management. How do I keep things up and running? And I like this definition, and of course all my ops team guys probably hate this definition, is Site SRE is what happens when you ask a software engineer to design an ops team. Now, if you go talk to people who are in the infrastructure as code space, they're going to tell you the same thing, infrastructure as code. Like the chef guys over here, I saw there's some chef people walking around, right? They'll say, well, that's what it is, right? It is how do I manage infrastructure and bring software engineering practices and software engineering disciplines into the management of infrastructure. So the term SRE might have started off last year or over the last 18 months or so, but the practices have really been around for a while. Oops. Something is bouncing over there in my, there's an alarm telling me I'm supposed to do a presentation. What did I do now? Hello, help. Okay. The wrong monitor is showing up. That's my email. That's my songs I'm listening to. Yeah. So I've developed this technique of learning new stuff. I go read up whatever I can. I go find people who are experts in that space, whether they are within IBM or outside in my clients. I talk to them. I understand what they're doing. I look at their work products, and I then go write a blog post about it. And ended up writing a series of a 3-part blog post on DevOps versus SRE. The second habit I have when I'm trying to learn something is I try to think of an analogy. What is this similar to which I already understand or which I'm familiar with, right? In fact, if you read my book, it's full of sports analogies. That's why I call it a DevOps Adoption Playbook. And every other page has some kind of a sports story on it, because I understand sports, and most people understand sports at some levels. And I know you all just do rugby, but there are other sports in the world. New Zealand used to play cricket, right? Do they still play cricket? Okay, somebody's going to throw stuff at me one of these days. So the idea is to compare it to something you understand, and then in your mental model you can fit it into an existing mental model and define it. That's just my technique. So I looked at a movie I had watched several years ago, called Apollo 13. Anybody seen this movie? Tom Hanks, right? So I started writing and saying, okay, what is this movie all about? If I think of an analogy of where somebody had an incident and how they responded to it, and how they succeeded in addressing that incident and restoring service. That's what SRE does. Here is a movie which talked about it, because here there was a space mission, and it's a true story, which had an accident in space. There's no way to go rescue them. They had to figure out how to land the spaceship and keep the astronauts alive in limited resources with a clock running out, right? That's definitely more stress than rebooting servers. So how did they do it? And in my opinion, the real hero, so actually after I started writing it, I said, dude, I haven't seen this movie for a decade, let me watch it again. And I realized my children hadn't seen the movie. My wife hadn't seen the movie either, so we watched it again. And here's the difference between my wife and children and I watching this movie. When they watched the movie, to them the real heroes were the 3 astronauts. They were the heroes of the movie. Tom Hanks and I forget the other people's names, the actors' names, right? To me, the real heroes, the people who did actual work, were the engineers at Mission Control, right? They had to make a carbon dioxide scrubber, which was round, for a filter which was square in space, right? You see the picture over there, and that's the picture on the far right, your right, is the actual astronauts, actual engineers in Mission Control. Yes, they're all white people, no minorities. They were all hidden figures. Some of you will get that joke on the way back. So they were the real heroes, right? The astronauts, all they had to do was continue breathing and not die. That's all they had to do. But these guys on Mission Control had to figure out what resources do I have in the spaceship which are working, what are not working. I can't send new resources there. How do I restore service with minimal loss of life and get these people back home? And that's what we try to do when you have an outage, right? I have an outage of a service. What am I trying to do? I'm trying to do MTTR, reduce my mean time to recovery. I am trying to restore service with minimal loss of data in as short period of time as possible. So a lot of similarities there. One of the things I also realized as I was doing my research on this is that most people do not understand availability numbers or reliability numbers. By training, I'm an electrical engineer. I did my undergrad in electrical engineering back in India. And in electrical engineering, especially if you're designing power systems or telecommunication systems, you always talks about 5 nines reliability, right? I did an internship in my junior year of college in a nuclear power plant. You want to learn reliability, you go and work in a nuclear power plant. They do reliability well, right? They cannot not do reliability well. But the default was 5 nines. Today, 5 nines, which is 99.999% availability, is unheard of in the web world. What does it mean? That means daily you can only have 0.9 seconds of outage. In a month, you can only have 26.3 seconds of outage. You have to be on and up all the time. If you even look at something more realistic like 99.95% reliability, which is a common SLO, that means you get only 43 seconds a day of downtime. So you have to keep your services up and running, and they can, if they go down, you have a budget of 43 seconds per day in order to restore it. In fact, at Google, in the SRE book, if you read it, they talk about having an availability budget. And every time you have an outage, you're using that budget up. And if you have a daily budget, even if you're down for like 2 minutes in a day, you have used up several days' worth of budget. And at the end of the day, if you want to maintain a quarterly availability number or an annual availability number, you cannot exceed that budget over the time. Over the whole year. If I lose 3 days' worth in one day, I'm now 3 days behind already. So a very unique way of looking at availability numbers. But this makes you realize, these numbers make you realize how tough the job is in today's high availability world and high reliability world to maintain services which can return these kinds of availability. So Google has done in the SRE book some very good work on capturing how they ensure it. Google never goes down, google.com. You do know that, right? How many of you have ever gone to facebook.com and on the top it says, facebook.com will be down on Saturday morning 4 a.m. to 6 a.m. for maintenance? Have you ever seen that? Never happens. You refresh the page and the new version is loaded. Now that's true continuous delivery with no downtime. And they're given some tenets. You can already see here there are some intersections with DevOps. You can see that there is a change velocity metric there, the second tenet. Change velocity has become a challenge because with DevOps, you're not doing continuous delivery. If I have weekly sprints or bi-weekly sprints or even monthly releases, which are going to production, every time that production release comes, my application is changing, my environment is changing, my data schema is changing, something is changing, and there is a new version which might not be hardened as much being delivered and run, which can create an outage because there are some unknowns. How do I prepare for those unknowns? How do I have a good monitoring scheme in order to maintain those availability numbers? You know what's the commonest factor I've seen as I've talked to companies about their inability to maintain some of those 99.999% availability? They don't even find out they have an outage till they see a tweet about it. The monitoring piece is so critical. And I'll talk a little bit about that in a later slide, so I'll come back to that. Change management, that's all about DevOps. How do I manage the change? If a new version of the application is coming or a service is coming, what other aspects in my environment, what other artifacts, configurations, data sources, connectivity, network settings, port settings, all of those response team processes, operational processes, what needs to change in order for me to maintain my service availability or my service level agreement which I have with my client to ensure I'm meeting that availability requirement. And of course, managing, forecasting, and all that is all very critical. There are 7 best practices also captured in the space of SRE. Prioritize, prepare, trust, introspect. You can say this is all, as they say, motherhood and apple pie, but these are all very important. And if you look at, and another thing, more pictures from the movie, the more you look at how they respond to the incident back at Mission Control in Apollo 13, you realize each and every one of these they exhibited. They knew what to do. They knew how to prioritize. Halfway through the movie, after the incident has happened on Apollo 13, they find out that they're not going to die because their battery is going to run out and they're going to freeze to death. They're not going to die because they have less oxygen because there are 3 of them instead of 2 of them in the lunar module. They're going to die because they're not scrubbing the carbon dioxide and removing it. They're going to die of carbon dioxide poisoning. And that's why that previous picture where they say, I would make a scrubber for my carbon dioxide, which is round, for a filter which only takes square filters. How do I create that? So they have limited resources, and they have to consider several alternatives in order to solve the problem. If you've seen the movie, you also realize they have battery issues. They don't have enough batteries. And the astronaut who's their substitute who's left behind, he gets into an actual lunar module simulator, which is sitting in one of the hangars, and starts practicing the landing procedures to make sure that the exact sequence is followed so they don't exceed the battery limits which they have, the ampere limits that they have. So all that is very critical, and those are all practices of what Google refers to as their SRE, as Site Reliability Engineering. And you can go into my blog and read more about it. So that's kind of my background on an introduction to what SRE is and what the principles come from. So let's jump into my actual talk, which is how does that intersect with DevOps in an enterprise? The biggest challenge we face in enterprises today when it comes to adopting DevOps at scale is that most DevOps practices, which you see out there in the literature of DevOps and all the work which has been done, usually tackles one release train or one delivery pipeline at a time. Which means everything about DevOps is focused on making my one release or one version of software, getting it from requirements to development to testing to pre-prod to prod as lean and efficient as possible, but they're only looking at one delivery stream or one delivery pipeline at a time. If you are a small shop, if you're 5 guys in the latte shop with a startup, it's no longer the garage, it's a latte shop now, right? That's where the startups begin. That's fine. You have one product at a time. Maybe you have 2. Think of something like Uber, one of the most valuable startups in the world. There are 3 applications. There is the user app, the one you and I use to call an Uber. There is a driver app, which the driver uses to respond to our request for an Uber. And there is the management app Uber has, where they track everything. And they have this thing called the God view, in which they can go look at what you're doing after you got out of an Uber, right? But 3 apps, very simple. Facebook, very simple, right? Simple architecture, not complex because of anything but scale. But you go into a large bank. How many of you have worked for a large enterprise, a bank or a healthcare or a government? Do you have more than 3 applications? Yes. More than 10? Yes. More than 100? More than 1,000? Yeah. I've worked with several banks where they have catalogs which are 2,500 applications, 3,000 applications, 5,000 applications. Most of those applications will have multiple project teams, each working independently of each other on a particular service or capability. They'll have DBAs which are on a separate team. They have a UI team. They'll have a middleware team. They'll have a queuing team. They'll have separate security teams. So this creates a challenge where you have several delivery pipelines moving at different speeds with different maturities of their practices and teams, different technology stacks, but they are interdependent. So we've been coming up with several models. The industry has been coming up with several models to help classify that and create some kind of a mechanism to manage it. Gartner came up with something called 2-speed IT first, right? Things are either slow or they're fast. That's a good, is it? I don't think it's a good way to classify. Who wants to be slow? And those who are slow will be always deemed to be the unimportant people, and the fast guys will be deemed to be the important people. Then they came up with another one thing called bimodal IT. There's one mode where you know all the requirements, and there's another mode where you do not know the requirements. That also is not a good mechanism because it changes over time. Second thing I do not like about these models is that they are not in business terminology. When you go talk to the business side, we as IT are serving, they are our clients, they are our customers, they are the ones funding what we do. At the end of the day, the goal of IT is to solve business problems and deliver business value. The business folks do not relate to mode 1, mode 2, high speed, low speed. They relate to things like value and risk. So some of us at IBM have created this model which is risk value based, where we are saying you can classify application across a spectrum. At one end of the spectrum, which happens to be shown at the bottom here, that's not to say it's good, bad, or ugly. It's just at the bottom of the slide because it has to be on one side of the slide, is what we call the industrialized core. These are applications which are keeping the lights on. They're running your business. Their value to your business is very high, but the risk tolerance is very low. So if an airline, your reservation system is here. If you are a retailer, your transaction processing system is here. If you are a bank, your core banking system is here. If there's any disruption here, you're going to run into trouble. Your business can have a lot of problems. The most important factor to success in the industrialized core is mean time between failure. How long can I go without having an outage? Right? It's like the factory floor which says it has been 389 days since the last accident. Right? On the other edge of the spectrum is what we are calling the innovation edge. These are applications where you're doing a lot of experimentation. It's the cutting edge of the business. You're experimenting with either new business processes or new technologies or new way of doing things. The value being returned to the business here is very low because a lot of experimentation here is still new. Risk tolerance is also very high. If it fails, there's no value being returned, who cares? It's a small project, experimental, it doesn't matter. It's a mobile app to do peer-to-peer payments. We are experimenting with it because we are a bank. So what if it fails? Right? We are not getting any value out of it anyway. All applications have to lie somewhere along this spectrum. If I go into any organization today which is a large enterprise, they will say that a majority of it is at the bottom half. In fact, it's in the 95th percentile is at the bottom half, towards the bottom half. The goal is to get to a normal distribution where things are moving up towards the middle. You have some which will be at the way cutting edge, very low value, very high risk tolerance, and some will always remain as very high value, very low tolerance of risk. But it needs to become some kind of a distribution curve, a normal distribution curve. In order to achieve this is a challenge. Because we as IT now have to be able to do the innovative experimentation kind of software delivery and the more traditional kind of software delivery, which is, while we want to move from waterfall to agile, might still have some very strict governance practices around it because the risk tolerance is still very low. So you have to be able to do both. Several organizations have tried to address this in many ways. One has said, we'll do all the experimentation in this digital group over here. Let those be the other guys. They're in that far-off table. If something catches fire, they're far away from us. But that doesn't work because their practices never get brought into the core systems. How do you create one IT organization which can do both? To me, that is where this marriage between DevOps and SRE becomes very important. By the way, I skipped talking to you about, I talked about the measure of success in the industrialized core being mean time between failure. The measure of success at the innovation edge is mean time to repair. You are assuming, because you're doing a lot of experimentation, that there will be failure. You're assuming you're in the cloud, you're building microservices because you'll need those kind of architectures, that there will be outages. The question isn't how often failure happens. The question is how quickly can I restore the service with minimal loss of value to my customer. So the thinking is very different at either spectrum, mean time between failure at one end and mean time to repair at the other end. Our research says that you have to get 6 capabilities in your IT organization to be good at. And these capabilities come both from DevOps and SRE in order to become a true organization which does this kind of what we at IBM are referring to as multi-speed IT and do it really well. And I'll talk about all 6 of these, right? And this is kind of the thesis of my talk here. And if you look at it, DevOps includes all of this. SRE is towards the other end, the right half of the slide. So these practices, if you start mapping them to DevOps or SRE, that's how they map up together. And it should really be not even rectangles. It should be a sloping oblong shaped with a Venn diagram and all, but I was too lazy to make that. I'm not that good with graphics, but if anybody has some great ideas on how to represent this better than this linear model, I'll be very happy to hear. So let's examine these 6 practices in the few minutes we have now. First one, architecture and planning. Understanding that architecture of your application and what the dependencies between them are becomes absolutely important when doing this. Otherwise, you can only go as fast as your slowest application. Oh, I want to release this service. Well, but I'm dependent upon service B over there, and that table over there, they haven't delivered on time. They are behind 2 weeks. I cannot deliver, right? Purposely, right? Yeah. Yeah. They were too busy experimenting with Kubernetes to figure out how to release this on time. I can walk into any company anywhere. Go talk to the CIO or CTO or enterprise architecture team and ask them, can you give me a dependency map between your applications? They'll scratch their heads and show me an enterprise architecture diagram which is at least minimum 6 months old. Then I make things worse. I say, can you show me the second order of dependency map? And then they don't want to talk to me. And if I say, show me the third order dependency map, that's when they throw me out. Because nobody has it. And I'm an enterprise architecture. That was my first job, right? I was an enterprise architect. Enterprise architecture as a practice has failed because it has become a documentation exercise, and it is usually lagging so far behind in today's world of continuous delivery that it holds no relevance. But in order to plan to do this kind of multi-speed releases where you're releasing at various speeds, at various technologies and maturities using different practices at the same time, requires a very good understanding of what the dependencies between your services are, of your applications are. Which brings me to the next part. How do I map those? Read that tweet while I'm taking a sip of water. If you cannot do a root cause analysis in an application, if for an application failure, when you have 100 applications and it takes you hours to do it, how do you do it when you have 8,000 microservices running? Unless you have a very good dependency map, an architectural diagram, and well-defined APIs decoupling the architectures from each other so that dependency becomes lesser and lesser. And you can isolate very quickly why an outage happened, where it happened, and when it happened. SRE requires that. Because unless you don't do that, the SRE team doesn't have a clue. It's a murder mystery trying to figure out who killed my service. So, capability number 1, architecture and planning. Capability number 2, using that architecture by using APIs to start decoupling that architecture from each other, all the components, as much as possible in an organized manner. Here's how you adopt microservices. You go read every paper and book you can find on microservices. 5 years later, come back and tell me microservices don't work, they failed. Because it has to be done in a much more organized manner than just breaking things apart and creating microservices. Practice number 3, managing your deployment and orchestration of your application and environments. In most organizations, we see that there is an application deployment and orchestration cycle, and then there is an environment and infrastructure deployment and orchestration cycle, and they are totally disjointed. They're done by different teams that don't talk to each other. That's the problem that results in this. Developers are paid to write code, not maintain deployment and configuration scripts, which means what? The operations team, the infrastructure team, the environment team should be delivering self-service capabilities for the developers so they don't have to write code to maintain and configure the environments on which they are running their application. They worry about the application, that the ops team worry about delivering the infrastructure environment as services to the developers to write code on against. Tonight, we test in prod. I can't do that accent, sorry. Gerard Butler's accent, I would have loved I could do it. If you're doing 2-week sprints, but it takes 3 weeks to get a test server, how long are your sprints? Usually at this point, I play a I Love Lucy video, okay? But the file becomes too big, and then people say post it on SlideShare or somewhere, and then the videos don't show, so I switched to this 300 slide. But the Lucy video is really funny because it describes this perfectly. It's Lucy and Ethel. How many of you, most of you are too young to know who Lucy is. I Love Lucy, you guys know? Others are too scared to say that they know who Lucy is because it discloses their age. But she was a comedian back in the day, okay? Black and white TV days, right? So she is at a chocolate candy making factory, and her job is to wrap the candy bars. And a boss comes and says, if you miss any candy bar and they fall off the conveyor belt, you're fired. She and her friend Ethel are wrapping it, and the candy bars come, they wrap it, they're like happy. Candy bar comes, they wrap it, they're happy. Suddenly the speed is getting faster and faster. Now they're eating the candy bars to keep it from falling. They're stuffing it in their pockets and other parts of their clothing, trying to keep it from falling. And that's what happens, right? You switch to faster and faster deployment cycles. Your test environments and test data and test availability becomes an issue. Service A is ready for testing. I am dependent on service F and Q. Service F and Q are not available. What do I do? I need data for testing because now I'm testing 3 times a week instead of 3 times a month. Oh, we don't have test data. Use the same data. How can I use the same data? I already use it. It's in my test database. I need more test data. I need to generate data. Managing that becomes the most critical bottleneck after a while. All of these are like rocks, right? You take care of the first layer of rocks, there are more rocks under that. You remove that layer of rocks, there's more rocks under that. You remove it, rocks all the way. I don't know if anybody else showed this slide, but it is a law that at DevOps Days, this slide has to be shown, okay? So I'm just making sure that we don't break the law. I put the slide in. And here is a quote from a VP of development at a military contractor in the US saying, Sanjeev, it is not possible to patch the software in the nose cone of my missile after it has been launched. Release management becomes very important because if I talk to a business owner of an application or a service, they don't care if my application is ready and delivered and running in production if the business service it is supposed to deliver working with other applications is not ready. Yes, Mr. Johnson, your loan application, you want to be processing loans using a mobile application, everything is ready, only people can't create customer IDs. How will it work? By the way, I'm just describing Obamacare without saying Obamacare, okay? I forgot I'm not in the US. In the US, people get upset if I use the word Obamacare and talk about how it didn't work because you couldn't create an account. Everything else in the website worked, but you could not create a new account. So nothing worked. So what use is me delivering 85% of all the services needed or 99.9% of all the services needed to deliver a business function if that one service is behind schedule and the business function cannot be released, is not working. When we go to a microservice model or a service-based model, it becomes the sum of all. The business value is what matters. My service is done, yay, I crossed the line, does not matter anymore. And operational readiness. And this is the key which I was talking about to you earlier on. Hey, I spent a lot of time looking for these memes, okay? So that's the only prep I did for this talk. This shifting of moving thinking of IT organizations, ops organization, from mean time between failure to mean time to repair is, to me, the essence of getting DevOps and SRE working together. Do you have Netflix here in New Zealand? Yeah? Yeah? Anybody seen Narcos? Oh, man, that's a good show. So I'm watching Narcos season 3. Pacho is about to kill Salazar. Okay? Episode 1. I won't tell you how he killed him. But there were 2 motorcycles and 2 ropes involved. So as he's accelerating the motorcycle and Salazar is screaming to him in Spanish not to do it, my stream dies. And I go, darn. Only I didn't say darn. I have to be PG-13 here, okay? So I didn't say darn, but I said some choice words. Here is what MTTR is. The stream came back exactly at that same spot within seconds, and I could see that body be shredded. I didn't miss a thing. That's MTTR. If I was watching live TV, what would have happened? Would have come back 5 minutes later, broadcast TV, right? Everything would have been over, and I would have been wondering, man, did his arms come off first or his legs? How did this guy die, man? I'll never know. So that's the difference between shifting from mean time between failure thinking to mean time to repair thinking. Netflix restored my service with minimum time, with minimum loss of data to me. They knew where I had lost the stream, they restored it, and they knew exactly where to start, so there was no loss of customer value. So in order to calculate MTTR is not that easy. Mean time to repair is mean time to detect. Remember I mentioned, you shouldn't be detecting you have an outage through Twitter. You should know when an outage happens. Next is mean time to triage. Is triaging knowing exactly where the problem is or having a murder mystery kind of issue? Trying to decode and decipher what is causing the outage. And third is mean time to restore. And if you work for some of the dysfunctional companies I've had the opportunity to deal with, there is also the mean time to pass blame. By the way, I'll post these slides, but if you are taking slide pictures, include me, okay, and this side is better than this side, so when I'm facing this way, okay, take a picture. But I will post them on SlideShare and tweet it out. You have to work on all 3 of these, and you have to remove the mean time to pass blame. You can do that later on. Have your blameless post-mortem, and then blame somebody so they can be fired. But mean time to detection requires a terrific, can't think of a better word, wonderful, great, but then I start sounding like some presidents. So it needs to have a very aggressive monitoring regime in order to know if you're doing microservices, and if you want to monitor the availability of business functions, not the availability of individual microservices, you need to be running synthetic transactions, which can detect when an outage happens, or there is degradation in response time. Knowing that, you need to have a very good architectural map. That's why SRE teams need developers in them, so that they can do a triage to determine exactly what is the cause of the failure, eliminate by process of elimination. And thirdly, restore. one of the tenets of SRE is let's figure out how to restore it before we figure out how to fix it. And these are key capabilities which are very important, and for most IT organizations, a major shift in thinking. Because the major shift in thinking is we'll patch it. We'll patch it in prod. That's how IT operations operate today before the SRE world. In the SRE world, that is not the way to operate. The way to operate is let's kill this server and replace it with a new one or an older one which we knew worked. I've been starting writing about this, and a few other folks in the literature world have started relying on this work done by Nassim Nicholas Taleb on this concept of anti-fragility. Nassim Taleb, if you haven't heard of him, is an options trader. He makes millions when the market crashes. That's all he does. He loses money every day. He has a fund, a hedge fund, which loses money every day, and he makes 1,000, 10,000 times return when the market crashes. So he's made millions of dollars, hundreds of millions of dollars when the stock market crashed for the housing bubble and when 9/11 happened. He is a wealthy guy because of those two incidents, and he's waiting for the next one. His idea is that there are people believe there are two kinds of physical objects, but he says there are three. First kind is things which are fragile. This water glass, it's glass, is fragile. If I drop it, it's very likely to break, right? This plastic bottle is robust. It won't break. Anti-fragile systems are systems that learn from chaos and thrive in chaos. So you're getting my point here, right? In order to achieve that MTTR status, to minimize MTTR, our systems need to be anti-fragile. Servers may go red, but services are always green. I have to assume that outages will happen. I have to assume servers will crash. I have to assume services will die. I have to assume memory will lock out. I have to assume AWS will have an S3 outage. I have to assume my local data center will go out. I have to assume my network will degrade because somebody is watching too much Narcos and is degrading the network availability, bandwidth in my availability. How can I make sure my services are still up all the time? At Netflix, they had a major outage a few years ago, and they lost several hours of streaming time because of AWS having a multi-zone availability zone outage. By the way, I'm just using AWS as an example. I mean, it could be IBM's cloud, it could be Google's cloud, it could be any cloud. The whole idea is outages will happen. Nobody can no matter, that's the whole idea of MTTR. You're assuming outages will happen, how can I restore it quickly? So they came up with this idea of something called the simian army. They have a tool called Chaos Monkey, which randomly goes and kills servers in production. You release it, it'll kill it. You release it, it'll kill it. The whole idea is to randomly kill it, and you as the development team have to build the service in such a way that it can handle it and survive it. And if it doesn't, you learn from it and make your service better. And they have Chaos Kong also, which goes and kills entire availability zones and says, can I still stream Narcos if an entire availability zone is out? People are now moving to a multi-cloud environment with multi-vendors in order to ensure it, because they are realizing that certain cascading outages in a cloud can take out the entire cloud vendor, like the S3 outage did for Amazon. So should I be spreading out my services across multiple vendors to ensure? And there you need to have portability across cloud vendors, and you cannot rely on their internal services, their proprietary services anymore, which means you have to make every service you make has to be made agnostic of which cloud it's running on. You cannot be consuming that cloud-specific services which are not based on any open standards. I like this quote. It came from out of the CERN, some work done at CERN in Europe. Cattle are not pets. The main thesis there is the reason we have fragility in our systems is because we have tried to make them too robust. Because we have focused so hard on this mean time between failure metric that when a failure happens, it is usually catastrophic. Instead, if we focus on MTTR, micro failures can keep happening. We do not have a macro failure. We don't have a catastrophic failure. Small failures, which if we have the right capabilities and practices in place, they can be restored. This requires wholesale organizational change. And I can go spend a lot of time talking about the Spotify model. Somebody talked about it today morning, Spotify culture, but they've also come up with some very interesting team models like the squad, tribe, guild model of how to organize your IT organization. With bringing on of SRE, you are now going to have SRE squads in place which go and tackle outages and ensure reliability of the services you are delivering. Lastly, organizations need to become learning organizations, which means every time an outage happens, every time there is a failure, every time you even succeed with restoring a service, you have to figure out why it went out and how can I prevent it from having another. Make the reasons of failure more and more complex so that there will be fewer of them. More and more things have to go wrong at the same time in order to have a failure. So here is my last slide, right? Kind of comparing DevOps to SRE. This is a T-shirt I saw at a large insurance company in the US. The T-shirt said, everybody is responsible for delivery to production. And this VP of development at that insurance company gave it to everybody. He gave it to all his developers. He gave it to all his QA people. He gave it to the ops people. He went to the CFO and gave it to the CFO. CFO, if you don't release budget on time and I have to furlough all my contractors, you are now responsible for delaying release to production. He went and gave it to the coffee machine vending person and said, vending person, maintenance person, if the coffee machine is out and my developers have now to walk 20 minutes to go get a latte, you are not delaying release to production. That's a mentality shift to say everybody is responsible, everybody has a role, and your role is, if you don't have shared responsibility, you're going to fail. SRE is saying, I have to take that thinking to the next level and say, everybody is responsible for delivering continuous business value. What good is my service running in production if nobody can access it? What good is my service running in production and running and being available all the time if another service is not available and running and people cannot get value, business value from my company? You have to have that holistic system of systems thinking and make sure everybody is on the same page and has the same idea of moving from mean time between failure to mean time to recovery. Why did I put everyone in parentheses there? Currently, the thinking in SRE is that there is a dedicated SRE squad. All they do is restore stuff and fix stuff and learn from it and then teach the developers what went wrong so that they can ensure it doesn't happen again. I think over time, as SRE and DevOps come closer together, those parentheses in that everyone will go away and it really becomes everyone's responsibility. Just like DevOps is everyone's responsibility to ensure there is shared responsibility of getting stuff to production, eventually they will merge as we mature, and we'll get to a stage where it becomes everyone is responsible for ensuring that whatever we deliver is continuously delivering value to our clients. Because at the end of the day, that's what matters. My project succeeding does not matter if your project failed, if we are interdependent. If I'm not dependent on you, I don't care two hoots. But if we are interdependent, then I definitely care.